Hello everyone, this is Yogini Samleti, Data Science Trainer at 7 Mentor. In yesterday's video, we saw what is data structure, what is data, its structure, what are the applications, and what is the need of data structure. Also, we saw algorithm, what is pseudocode, and today we are going to continue with the next part, with the second part. Today we are going to see how data structure works. So let's start, guys. Okay, so I have made a statement here. Python makes data structure simple but powerful, and that is true. So let's start with the data structure working. Data structure are of two types: built-in data structure and user-defined data structures. Built-in, it is already ready to use in Python, and user-defined, where the built-in doesn't fit in your problem perfectly. So you can create your own custom structures using the classes in Python. So today we will deep dive into built-in data structures which are ready to use. So first we will see what are the different built-in functions. Data structures. Yes, it is list, set, tuple and dictionary. So let's start with list. List is the fundamental built-in data structure. It is the basic data structure in Python. It is highly versatile. Here we can see it is highly versatile, means it is used in different sectors, or different uses can be done with the help of list. Okay, and it is commonly used data type. Why it is commonly used, that we will be seeing in the coming video. Yes, it is dynamic array. Dynamic means the size of the array is fixed. List is highly versatile, different uses. It is used in different purposes. Also, it is commonly used data type. List is also a dynamic array. Dynamic, it means the size can be changed of the array. Okay, so size of the array can be changed. It is mutable. Mutable means you can change the elements of the list. Okay, it is heterogeneous. Heterogeneous, it includes different data types. Like in a list A, you can have integer, float and also string. So this is allowed in list. And also duplicates are allowed. You can write 2 twice. Okay. Yes, different operations are performed: append, insert, extend, remove, pop, clear, sort, reverse, etc. These are the operations performed on list. Backend working of list in memory management, I'll just explain you with this example. Okay, so first we will see all the attributes of the list. When array is located, actually the heap memory is located via OS, from OS via C memory allocator. See, in memory management, this is your heap. This is your heap memory. Operating system doesn't give you the whole memory. It only gives you a part of memory, which is the heap memory. Whatever the initializations, variables, array, list, tuple, set, dictionary, the addresses are stored here. Now you might be wondering what addresses, what is this addresses? I'll introduce within a while. Okay, so this is heap memory. Python doesn't directly interact with the operating system's memory. Okay, yes. Example, 1 million integers are not stored directly, means what? I'll explain you with only 5. Suppose these are the 5 integers. So the integers I will write here 1, 2, 3, 4, 5. So when we write A is equal to, B is equal to, C is equal to, D is equal to, and E is equal to, we write 1, 2, 3, 4 and 5. This is at the user end, but at the hardware level, A is equal to, it is the address. I am just writing an example, okay. The memory address can be anything taken by the operating system or the heap memory management. B will be 0 into 0fx, C will be 0 into 1h, 1f, D is equal to 0 into 04, likewise. So here the addresses will be stored, and at this address the values are stored 1, 2, 3, 4. Okay. So why this, how this happens, we will be seeing in a while. So this is a small statement that 1 million integers are not stored directly. Instead, the pointers or the address are stored in the Python object. Python is an interpreter, okay, so it always deals with the objects. Yes, list grow and shrink. We will be seeing this also in an example, very easy to understand. Okay, so let's come to an example. I have written here A is a list 10, 20, 30. So let me draw. I'll erase this off first. I'll take some different color. Okay, see. First I will take a temp variable 50. Okay, so how list work at the back end or in the how the memory management is done in list. So this is address 1, address 2, 3, 4, 5 and 6. Just for the example I am taking only 6 addresses. So when I write temp is equal to 50, this 50 value is stored here, and in temp I'll write this with another color beat. This will be good. Okay, so here the address will be stored. Temp is equal to address 1. Okay, now we will take some I'll do one thing. I'll take an array now. A is equal to 10, 20, 30. Clear? Now see how this works. When I ask him 10, 20, 30 to put in a list of A, 10 will be stored here, 20, 30, and A will be having its address. I'll use another color. Wait. Yes. See the address 2. 10 addresses 2, 20 addresses 3 and 30 addresses 4. Clear? And suppose again we want to insert, yes, we want to append. Let's suppose I want to append A dot append. When I write only append 40, it will automatically append at this address. Okay, but when I write A dot, and yes, also here it will have the address, what is it, 5. Yes, so it will be having address instead of the value. When I write append 50 comma 1, we will take 1 as example. I want to append 50 at the index value 1. So what I'll do, I'll show you here how this works at the back end. This address are shifted downwards. So this is index 0, 1, 2 and 3. Okay, clear with this? I want to append 50 at this. So what that does, wait, I'll use one more color. We have so many colors we can use, right? Okay, so address 2 will be having 10 itself, and now at address 3, as it is the index first, 50 will be appended, 20 will be shifted at the next, and so on. 30 will be shifted, 40 will be shifted at 5 and 6. Okay, so at the back end or at the hardware level, these operations are performed accordingly. Easy to understand? Okay, so we did append 40, we did 50. Okay, I would like to tell you, in data structure and algorithm, time complexity is very, very important. Time complexity and space complexity, these topics we will be seeing in next sessions. But I'll just introduce you how this works at the program level. So to append, okay, so we are appending it. So there the time complexity is linear. Okay, for appending, see, in list we can append single items. It will take same time to append single item and to pop a single item. But if this is at the operation level, but at the same time the list size is increasing by how much? Sorry, just give me the spelling mistakes. Okay, it is increasing. So what is the length here? This is 3. Let's say length is n here. So by how much it is increasing? It is increasing by n. So big O notation is for time complexity. We can represent it as O of n. So if we are doing some operations appending, then it is increasing and the time complexity is O of n. Clear? Okay. So, and we saw O of 1 and O of 1. When we append, it is O of 1 because it is linear. It takes same time to append any of the values. Okay, I'll give you a simple analogy of library. Suppose in a college you have a library. Okay, let's suppose each page is a shelf, each cache is librarian, the person who gives the books or who issues the books. Okay, if ask for a book A of 2, okay, I am taking the example A of 2 so that you can make an analogy with the list elements and with the library books. And if it is near, let's suppose if it is there in its library, the where librarian is working right now, where he is there. So he will immediately take out and he will give it to you, hand over to. Instantly cache is hit there. But if suppose it is of some what we can say psychological department, okay, I don't know the spelling, okay, so psychological department, let's suppose it is psychological department, and if it is not present in his room, what he will do, he will refer to a book where different department books details are there. So he will check, okay, it is in room number some 49. He will ask you to go there and take the respective book. So this 49 acts here as a address. Can you just make an analogy? This is 49 and here is your psychology book. Clear? Okay. Yes. So, and he walks across the building, okay, and then he finds and gives you, or he gives you the address. Any one can happen. Okay. So Python list asks you twice. So see what we have seen here. We can observe one thing. This is my list. These are my elements. Am I directly able to access the elements? No, I need to go to the address. Then the address gives me the values. So Python does Python list gives you, asks you to give twice, right? One for the pointer and one for the data, right? We can make an analogy accordingly. The example of list is our Amazon cart. Whenever you do the shopping, okay, whenever you do the shopping, let's suppose you buy one dress, okay, you need to buy a dress, you put into the cart, okay, this is append, this operation is append. But after some days you feel no, this is not the good color, I don't like it, you again remove it. You can remove it, right? So this is append and this is pop, is remove. Okay, yes. Rewritable series, previously we used to have rewritable series where you can write the series in the series, means you can add the data in the CD, okay, add the data in CD, and if you want to erase, you can erase it off. Okay, so this is the example, real-time example of list. Yes, coming to the tuple. Tuple looks similarly to list, but it works differently. Like mutability, it is immutable. Tuple is immutable. Allocation, only the fixed size memory is allocated. Fixed size memory is allocated, so it behaves differently. Okay, simple and small in size, as Python doesn't need to track extra capacity or resizing, means it doesn't need to allocate more space. Suppose we have an example, t is equal to 10, 20, 30, yeah, it is there, this example is there, right? So it will be allocating only 3 memory, it won't go for the 4th, okay, this like this, okay. This is fixed, the operating system will not increase the memory here. Internally, single contiguous block for tuple object pointer array, okay, means it has only a single block. This is the single block for pointer array. Initializes the pointer to null. Okay, these are some properties. No resize means fewer cache misses, means the cache will have less number of miss. Okay, and simple structure. Yes, if you want to access A of 2, it will directly go to the, see here also the addresses are stored, but it won't just wait for the number to come, it will just check one by one, and that's it, because it will run the loop 3 times and you will get the element if it is present in it and gives the value. Okay, safe to store as dictionary keys, no fragmentation caused by resizing. As tuple doesn't change, it is used as dictionary keys. Okay, and the application here we can have CDs. You know, you have software, or previously we used to get the operating system CDs. You can't write in that. Whatever the data is there, you have to just have a look, you have to study in that, that's it. You can't change it. So that is an example of tuple. That is an example of tuple. Also, we can say latitude and longitude. Geographical coordinates, these are also fixed for each place. Okay, so this is the example of tuple. So today we saw the list and tuple memory management in detail. Okay, so in next session we will be seeing set and dictionary, how they work, what is the importance, why were they introduced. Okay, till then, see you guys. Thank you.